Hello, everyone. Good morning. So we have about approximately, I think, around 11 attendees so far. We will begin in exactly 2 minutes. All right, we are about to begin. All right, then. Firstly, good morning to everyone who has attended. Thank you so much for investing a bit of time for us. And we have a very interesting topic ahead. Firstly, good morning to all of you. And thank you for joining us today on behalf of Tecs. We're pleased to welcome you to this focused session on seismic design and code compliance for MEP systems. This webinar brings together engineers, consultants, and project professionals who play a vital role in ensuring safer, compliant, and resilient building systems. I'd like to just simply walk you through the structure of our event. We have the duration of the webinar is about 45 minutes from 10 o'clock a.m. to 10:45. A question and answer session will be there. So we hope you could reserve your sessions, or you could even input your questions in the Q&A box just above. There's a small button there called Q&A on top. If you can see it, just kind of click that and enter your questions. We will address them all by 10:45. And the poll at the end of this session, we would love to hear your feedback on the session conducted. Therefore, we can improve the experience as we go forth. Yes? So, a few more tips for you attendees. We would please advise everyone to use Google Chrome or Firefox as your browser. Therefore, the experience would be smoother. And likewise, please do not enter into any parallel downloads as you were joining the session. So at least you don't experience any, uh, you know, any technical issues. Therefore, questions will be answered at the end. And once again, technical supplies. We have our divisions are composed of electrical, instrumentation, oil and gas, mechanical, lighting, tools and core cutting, and drives and automation. And likewise, I'd like to introduce our first speaker, Mr. Engineer Rajesh Talapaneni, a structural engineer with over 10 years of experience in steel structures, seismic design, anchors, facade systems, and MEP support systems. He holds a master's degree in structural engineering with a focus on seismic design and skilled in leading industry software. And we also have our next speaker, Engineer Wazid Sheikh, who brings uh, over 20 years of experience in strategic business development and projects and sales. Yes. So with that said, to our introduction, may I please hand over the controls to Mr. Rajesh Talapaneni, our first speaker.
Thank you, Marion. Uh, Good morning, all of you. Welcome to today's webinar session. This is our first webinar from Technical Supplies. Today's topic is seismic design and code compliance for MEP systems. So, any building, if we take, we have two different components: structural components and non-structural components. So, structural components are basically the columns, beams, and the slab. And non-structural components, which is our focus today, are like MEP services and equipment like air handling units or AHUs, and trays, piping, and ducting, which compromises of MEP services. So we will be discussing about non-structural components and what is the requirement of a code when it comes to MEP, especially the seismic requirement. So moving forward, today's here is the content for today's presentation. Yeah. Introduction and code references, Oman seismic map and soil class in Muscat area. So to be more interactive and more practical, we will be taking a project location. Uh, Assume that there is a project which is located in Muscat, Gala area. So I don't want to name a project name. So just assume that there is a project which is located in Gala. And building category, seismic design category, and component importance factor, which is a very important aspect of this today's presentation, and what is its role in selecting a seismic support. And followed by seismic requirements for multiple MEP services, starting from electrical, plumbing, ducting, and firefighting services. And in firefighting, we will be discussing about NFPA as well, and also some special cases like floor mounted equipment and rooftop equipment we will be discussing. And last but not the least, we will be discussing, presenting the solution services that Tecs can offer when it comes to seismic requirements. Yeah. So the first question should come, seeing the title, or when it comes to seismic, we hear every day there is a seismic activity somewhere in the Arabian Sea or somewhere in Turkey or somewhere in Europe. Every day we see a news about seismic. So do we really need to worry about this aspect in Oman, or is the seismic bracing is really required for an MEP services? Because most of the MEP services will see that 30 to 40 kg per meter when it comes to the services which are running in typical residential or commercial buildings. So there are two thumb rules when we talk about seismic bracing and its requirement. The first thumb rule, or the first important principle for a designer or a consultant or a contractor, is the life safety. So life safety is the primary goal of seismic design. So this ensures the occupants are protected during an earthquake, even if this building experiences any seismic incident or seismic activity. Say, let's take an example. Let's take an example that you see there is a chandelier. Yeah, there is a chandelier which is swinging vigorously, and when there is a seismic incident happens, right? Here, whether the chandelier falls down or not, that's a secondary aspect. But what happens to the user here? What happens to the user safety here? So the occupant will get into a panic situation that he will not be in a situation to accommodate in that particular or the building. So there starts a mess that everybody will try to access the exit gate or assembly point, and then it's a huge gathering. Then you can imagine what is the disaster that can is going to happen. So coming to this seismic design, designing for life safety is minimizing the risk of injury and giving occupants a peace of mind, even such earthquake or seismic incident happens. So moving forward, the second important principle is the functionality. So we discussed about life safety. So beyond life safety, there comes the important aspect is functionality. Why functionality is very important is it ensures the building is remains usable and it comes to operation or work as quick as possible post the earthquake or seismic incident happens. Like I'll give you an example. So let's take a hospital or let's take a power grid, which are the primary important buildings or structures that need to ensure their operations or work is not being affected when there is a seismic or earthquake incident happens. If any of these important structures got damaged or disturbed, during an earthquake, what happens is that it will not come into operations. Yeah. So it will not come into operations, and there the occupants and the public will have no access to such facilities because already the disaster has been done. Yeah. So these are the two primary importance which needs to be taken care. Then moving forward, I would like to give another example that in 1994, there is an earthquake which happened in California. It's called Northridge earthquake. So if you Google it, there is a lot of articles, lot of you call it, journals, and a lot of codes has been amended um, on this particular aspect. So what is the major problem in this particular earthquake incident is the structural components are remain intact. Means the slabs are very good, the beams are very good, the columns are still intact, and there is no any issue. But the problem happened is with the secondary structures or the secondary structure elements like false ceiling or the MEP services, where you could see the actual pictures of this earthquake incident, how the structures has been damaged. So what is being actually happened is that the most of the hospitals and water pipelines has been broken, the glasses has been broken, the facade has been broken. So the pictures what you see on screen are a school classroom where the entire false ceiling is being collapsed. So this is where the major disaster happens. So such incidents will give us a strong indication or a guideline that we must design our structures, especially the secondary structures, for post-earthquake functionality, not just for survival. Yeah. So this is the same thing that need to be considered. So moving forward, so for today's session, we will be focusing on American Standard, which is ACE7, which is again interlinked to IBC, International Building Code, yeah, which is International Building Code, ACE7. And there are new versions which is being released. However, the main major intent or the guidelines of seismic requirement are still not changed. So in ACE7, there is chapter 13, which specifically highlights or the requirements of basic designs need to be followed for secondary structural elements. Yeah. So again, this AC7 is interlinked with IBC, NFPA, SMACNA. So this follows the interlinking of multiple codes. So where these code references will be given at the end of this presentation. So moving forward, for seismic design, we need four key inputs. Either it's an engineer, or it's a consultant, or a contractor, or a client, or a specifier. Anyone who needs to study about the seismic design or the supports. So what the major important aspect is, we need four different parameters or four inputs, which is the seismic zone, and soil class or soil condition, or the building category, which generally comes from the specifications of the project, or we will see how this building category can be arrived through the codes. And also, we need to know the seismic category. These are the four important inputs that we need to have in hand before we start any seismic design. So we will see how these inputs we can arrive and where to refer and what codes to be referred to gather this data before we start. Yeah. So the pictures what you see on screen are actually the extracts from Oman Seismic Code, which is being published by Sultan Qaboos University Earthquake Monitoring Center. So these are predefined data. So like on right side, if you see, there is a seismic map where you could see this seismic map is generated taking last 475 years of time period. And this entire Oman is been categorized into two zones, zone 1 and 2. The one which you see on the top, blue color is the zone 1, and the bottom one, which is in green color, is zone 2. Yeah. So as I said that today we are going to discuss about a project which is based in Gala area somewhere. So with this map, we can identify the project or the site location falls under which zone. So that is our first and primary requirement in our previous slide, zone. What is the zone? Zone 1. Yeah, so we got the first input. And the second input is the soil condition. Mostly there is no soil map, which is currently available, um, as far as I know. So mostly there are soil classes which has been defined in the code, starting from A to E. A is the best soil or good for um, like hard rock, which is very good for seismic incidents. I mean, the building will not get affected. So starting from A to E, the more it goes till the E, it's soft clay, where you need to give a lot of importance to the earthquake, and even minor components needs a lot of heavy design and restraints. So typically, I'm assuming for this particular case study, what we are going to discuss is falls under C, very dense and soft rock. So mostly if you see, this is being again derived based on the site to site. We have a lot of geotechnical surveys which is being done, taking the soil samples, and then we will arrive what is the class of soil that is being located at particular site. So mostly it is being varies from project to project, location to location, or country to country. So a valid testing is very important to define the soil class. Yeah. So now we got two inputs. Yeah. So we got the site location. I mean nothing but the geo and the soil condition. So moving forward, building category is the next aspect. So this building category can be given by the consultant or the specifier in the project specification document, which defines building falls under category 1, 2, 3, and 4, or it varies. In some codes, it refers to A, B, C, D, but end of the day, the core intent remains the same. So now I'm taking an example of a public assembly building where the occupants at any given point of time will be more than 300, like an example of convention center or a function hall, where you will see a gathering more than three, which falls under category 3. So there are predefined building types, like hospital, if you take, it falls under category 4, like hospital with surgical facility and emergency treatment falls under category 4. So with this basic guidelines from code, we can decide which category the building falls. So I'm assuming that the building is falls under category 3. So with this, we got the fourth input. So now moving forward, the first three inputs what we discussed is the zone, and then the soil classification or soil condition, and then we got type of building or the occupancy category of the building. With these three, we will derive the seismic seismic category of this particular building. So which category this the building falls. So there are total six categories. Sorry, there are total four categories in seismic, which is starting from A till the D. If any building falls under A or B, means A is the most safest, and the more you go down till the D, D is a little critical, where we need to put a lot of restraints or seismic design need to be carried out. So coming back to our case study, so we took zone 1, which we got the data from previous slides, and soil class also we know. Then we got two values here on the screen. So what you see here, if you see the heading of the table, this is also an extract from the seismic code. So it says that short period acceleration or response time period. There are a lot of terms. And then we got 1 second elastic spectral acceleration. What are these terms and what are these factors? I have highlighted two factors related to SDS value and SD1 value. So what are these factors? So these factors are nothing but assume that you have a small building, okay, and you have a very large building, um, or to be more precise, and a simple example is that you are holding a spring and there is a small mass which is attached on top of it. Yeah. So you got a small spring or a string in your hand and a small cork or a ball is attached to it. So when you apply a movement at the base, so what happens is that the small structures will not have major movement when the movement is small, right? So when you have a larger movement at the base, like when you have a huge base shear, what happens is the structures oscillates vigorously. Yeah. So, I mean, in simple terms, I would say that the short period acceleration is for the buildings of small height, like residential buildings, villas, or individual houses. So where this short period factor needs to be considered. What is elastic spectral acceleration for 1 second? 1 second is that just assume that we went to a park. There is a swing where a child is sitting and then swinging. What happens is once you apply a force to the swing, it goes to certain distance and then comes back. So there is certain time period. It's not very instant, right? It goes and then come back. So there is certain time which is being taken. So the same principle happens in the large building. Assume that you have 30 to 40 floors building and the seismic incident happens. It will not oscillate so fast. It will oscillate like a pendulum. It goes and then come back. So here the behavior of seismic incident is very different. When you take a short building, it oscillates vigorously, but whereas a bigger building or a larger building, it acts as a pendulum. So both the scenarios has to be taken care when we talk about the seismic incident. Um, sorry, yeah, sorry, there was an interruption. Yeah. So with those values, what you could see on screen is we got the short period acceleration factor and the long period acceleration factor. So with these two, we will define our building category. Whereas what are the values we took? I have highlighted here where these factors falls under according to your soil class. So with that, we can arrive the seismic design factor. So certain codes give us this predefined data, which is pre-calculated in the tabular format. So it's easily we can refer and then get back the details. But certain codes give some empirical formulas where we need to, again, it's very simple this way. The more the mass, the more the height. Mass versus your acceleration due to gravity, which will define our base shear value. So we will calculate our factors and then we will derive our seismic category. So we are taking both into consideration short period response and 1 second time period response. And whatever falls the critical category, like in short period, it falls into category B, but in 1 second time period, it falls into category C. So our seismic category is considered as C. So this is the primary aspect that defines what kind of restraints or to what level of seismic design that we need to carry out for that particular building is purely depend on the seismic category. So I'll just give you a short example that if it's a hospital building, if it falls in the seismic category A, so most of the seismic supports can be avoided. So selecting a seismic category plays a vital role. And when we are selecting a seismic category from B to C, I'll give you a rough example that the contractor or the client can save up to 15 to 20% of the value, I mean, the total project value, which is can be saved or can be avoided when the category is being selected from B to C. So this is the variation that gives when we talk about seismic requirement. Hope the slide is clear. So moving forward, if you have any questions, we will be discussing at the end. And the next important factor is, so we got so much data now that yeah, we talked about soil, we talked about seismic category, we know what is related to our building. Now the building has components. What we discussed in the first slide is the main primary components, which are slab, beam, and column, and the secondary component, which is importance factor. So these importance factors are nothing but the services. Like you have a component, like MEP pipe is a component, firefighting pipe is a component, tray is a component. So each component has its own importance factor. Say, for example, importance factor can be assigned according to the code or according to the specifier requirement or the client requirement. Is assigned to components where the failure would not impair the building function or cause significant hazard, right? So if the specifier has a strong evidence or the code says that failure of this pipe will not obstruct the operation or the functionality of the building, then the importance factor for which component can be given as well. But whereas if any of the failure of such services will drastically impact the building and it affects its operations or the intent of the building design, then the importance factor should be given as 1.5. I'll give you an example that if you have a water supply pipe which is going to a mechanical room, where the mechanical rooms are mostly, storage room, I would say. So were used once in a while. So if there is a water provision there, if it gets disturbed during an earthquake incident, which will not affect the entire building. But whereas if the same water pipe or same freshwater pipe is going into an operation theater, which will have a drastic impact during an earthquake incident, maybe some patients might, outpatients might be there. So such incidents will drastically impact the functionality, and it will, again, going back to the principles, it will affect the life safety of the user, right? So such scenarios we should must here. If you see, the component remains the same, the water pipe remains the same, but its functionality is changing from room to room or project to project or place to place. So based on that, we need to provide our seismic requirements. Yeah. So moving forward for electricals, if say this is a case study, as I mentioned, that our building falls under category C. If the importance factor is 1, so there is no need of providing a seismic brace. So we can just drop with the threaded rod a regular hanger type support, two threaded rods and a channel, and then we can leave it. We don't need to brace it again and do some additional seismic design. But whereas if the importance factor is 1.5, we must need to provide a seismic bracing. But there are some limitations. Like it doesn't need that you have a 1 inch pipe, 2 inch pipe, which doesn't need a seismic bracing, even if it's 1.5 factor. Because when we talk about seismic, we talk about the weight. Weight plays a major role, and the drop also plays a major role. Yeah. So any pipe that has a diameter 65 or less doesn't need to have any seismic brace, or 2.5 inch. So above those, which pipes, conduits, cables, or cable bunches, cable trays, so or conduits, so these all must need to be seismically braced. And similarly for trays, bus bars, bus ducts, baskets, ladders, all these having a weight up to 15 kg or an individual unit or light fixings, which has 15 kg unit as a weight. If it is less than 15 kg, we can avoid seismic bracing. So anything beyond 15 kg, we must need to provide a seismic brace. And also the 12-inch thumb rule, we call it, or 300 millimeter approximately. So where if any of the service is being dropped from the slab or soffit level, so the distance from the bottom of floor slab till the centroid of the service, that is very important. We need to consider the centroid of the service. If it falls less than 300 millimeter, we can avoid seismic brace. But so given that all of these three conditions should meet the requirement, so if any of these are not meeting requirement, so we cannot avoid seismic bracing. So if it complies to all these three requirements, we can avoid. If any of these are not compliant, then we must need to provide a seismic bracing. So moving forward to plumbing. Plumbing is also more or less the same as electrical. Only difference is that the electrical services are different. There is straight pipe here, but the concept remains the same. The principles remains the same. So ducting has a unique different approach compared to electrical and plumbing. So any duct that falls, the importance factor criteria remains the same based on the building design, existing design category. So if any duct that is falling less than 0.56 square meters or 6 square feet, and the running weight should be less than 25 kg per meter, which includes everything, your support, insulation, duct. If some, mostly the gases will not have major density, still the weight of either the gas, smoke, whatever is being passed through it. The whole support weight should not go beyond 25 kg per meter, and the size cross-sectional area should be 9.56 square meters. So if it is less, we can avoid seismic bracing, but if it's beyond this, yes, we must need to provide a seismic brace. And given that, if any given situation, the duct that carries toxic, flammable gases, smokes, must need to be braced. So what happens is here, these are not the functionality issues. These are the life safety issues. Any of these get leaked during an earthquake incident, which will affect again our life safety. So that's very important to be given. So meeting the two requirements of life safety and functionality, we need to choose the support. And 12-inch thumb rule is not possible in this because the ducting has a different approach, because the duct comes with huge, which is hollow. So 12-inch thumb rule is not at all possible in this. Yeah. And the special cases are, we have two special cases where if any roof-mounted equipment, either it can be chiller, water tank, AHU, or your FCU, fan coil units, anything that is floor-mounted or which is mounted on the roof, if the equipment is standing at 1.2 meter height, I mean the support height, the bottom of the equipment, and with an importance factor of 1, means it should not affect any of the operations of the building, even in case of failure. So such cases we can avoid seismic bills. And case 2, if an equipment which is freestanding on the floor and which doesn't have a motor, it is very important that the equipment should not have any motor. It should be a static equipment. And this equipment weight should be less than 1.8 tons. And again, importance factor of 1 doesn't need any seismic weights. If it's not compliant, we must need. And then case 3 is what the development of case 2 is the vice versa. If any equipment that has a motor of 10 HP and that must have to have a seismic restraint, or we are going to anchor the equipment to the slab, right? So the anchoring point must have a seismic anchor, which is tested for seismic. So you can always ask the manufacturer or the supplier for an evidence that my building is complying to seismic so and so. So I must need an anchor which complies to seismic requirement, and there you will get a document which is shows the tested values under seismic category. So with that, we move on to firefighting. Firefighting has only one principle, that any pipe that is 65 mm and above must need to have a seismic bracing. And this is the only principle that is applicable where we cannot avoid much of seismic bracings. So moving forward to discuss about seismic in firefighting, I will just give you an overview of an FPA 30, especially for the hangers and supports. Every support must need to be designed for 5 times the water weight, the self weight of the service, plus 115 kg, which is being shared with every hanger support. So the 115 kg should be designed for every hanger support. This 115 kg is specially allocated for the firefighters during the fire accident. So they will take the safety hook and lock it to these supports, and then they can move inside, because this gives a path. Because the sprinklers will be suppressing the fire incident, so this will act as a pathway to go inside the building. And the minimum rod diameter must be 10 millimeter, and the components directly attached to the pipe must be listed. Means now we will see the further slides. So we have a seismic brace where you got an attachment to the concrete and there is an attachment to the pipe itself. So these two attachments must be listed. Means it should have either UL, FM, or any approval which is accepted by the local civil defense or the local jurisdiction. So this is very important. So, and we can, the in between connecting rods, threaded rods, any mechanical components doesn't need to have any listing. So it can be a threaded rod, angle pipes. They are not, they doesn't need to have any listing or approvals. But the components like anchor fasteners or the pipe clamps, those are very important, which must need to have a approval. So the maximum distance between the hangers, this is again being in the code, which I'm just giving you an overview. You can also refer to an FPA 30 where all this data is being clearly mentioned in chapter wise. So this is the basic requirement of firefighting supports. So there are two kind of braces: lateral brace, which is always parallel to the support, sorry, perpendicular to the support, and sway brace, which is in the direction of the pipe, or which is parallel to the pipe. So the maximum spacing that need to be followed, or maximum spacing that can be considered in a seismic for lateral brace is 12 meters, whereas the longitudinal can go up to 24 meters. But given that there are certain conditions, which we will be discussing in the next slide. And the minimum rod diameter for the suspended is 10, which we discussed already. And sway braces distance to the end of service is 1.8 meters. So this also will present you in a pictorial format. So all braces must comply to L by 300 slenderness ratio, which is called L by R limit. So this limit is what the most critical part for firefighting is. Most of the threaded rod braces can maximum span. So when you have a diagonal brace for the pipe, the maximum threaded rod can be used. Say I'm taking M12 as an example, is 650 to 700 millimeter length. So beyond that, if you are providing, we are not complying to the code. So ideally for firefighting pipes, pipe bracing is very important because pipe has higher slenderness limits where you can span up to 2 meters. So this is again comes like based on the length of the brace, we can select the diameter of the pipe. So this is a typical example how this firefighting bracing arrangement is being given. So what you are seeing a plan layout of a typical firefighting pipe. So you see there are two arrows which has been indicated. Hope all of you can see my cursor. So there are two directional here. So this is the starting of the service. So as I mentioned previous, the lateral support can be up to 12 meters. So this is the lateral support. Again, there is a longitudinal and lateral support here. So the span between lateral to lateral is 12 meters, which you see here, and the span between longitudinal to longitudinal, yeah, is 24 meters. And so this is condition one. And the condition two is every elbow must need to be restrained or supported at 600 distance. So the distance between the supports on either direction must be 600 millimeters. So what we are discussing here is 600 millimeter. So this must be 600 millimeter on either side. So we got on either side of the elbow. So these are must installed supports when it comes to Seismic for firefighting. And one more we discussed is end of service, we have 1.8. So this is your service end. So from service end, the maximum inside, the maximum we can go is 1.8 meters. Is where we can leave the support as a pre-cantilever where you can keep a sprinkler. The provision will be given to sprinkler especially. So this is the maximum length that can be avoided. So beyond this, we should not allow the pipe without a seismic brace. So these are the basic principles that needs to be followed according to NFPA when we are discussing about the fire. And then moving forward for the riser supports. So this is also one of the important aspects that if you see any of the buildings, risers plays a key role. So this is the riser clamp, which must be placed or which must be designed to accommodate the pipe vertical weight, which includes your thrust weight and which includes your pipe weights itself. So the maximum distance that need to be followed is like, as a thumb rule, it's like every alternative floor or 7.6 meters is the maximum that need to happen. Means every alternative floor, we must need to provide a riser support, which is actually designed to take the vertical load as well as the horizontal load from the pipe itself. Yeah. So so that's all about the LEP non-structural components and the seismic requirements. So out of the subject, there is one special application which is related to the civil, which must be complied when it comes. Is just I just want to share this, and also since I don't want to leave this alone. So these are head of all restraints, what you see on the screen. Yeah. So all the blockworks, as we all know that the blockworks are freestanding, right? That they don't have any restraints. That slab load should not get transferred to the blockworks. So they are non-load bearing ones. But what happens then? So there is no non-load bearing. There is no attachment or the fixing done to the slab because this movement need to be allowed. So there comes a major important aspect is during the earthquake. Again, going back the pendulum concept. So this block wall has a tendency that it can move left and right, and then we end up seeing cracks. Sometimes it falls down. So such scenarios, we have to go for an angle restrainers, which are fixed onto the slab, but not onto the block work. So if you closely look into this, the anchor points are onto the slab, but it is empty onto the, there is no anchoring point onto the block. So it will restrain the block wall not to oscillate or not to get impacted because of the earthquake. So, and how anchor needs to be given, at what interval needs to be given, whether continuous retaining angle is required or we can split it like 500 or 600 millimeters. This is purely again based on the blockwork height, the density of the block. Again, mass is involved. So based on the mass in the building seismic category, we will arrive the base shear value and then we will finalize the design. So with that, I would like to hand over the next slides to my colleague, Mr. Vasu. Thank you.
Yeah. Thank you, Rajesh. Thank you very much. Good morning once again, dear guests. Now that you have understood the codes and what kind of code compliances are required for the seismic activity, now I'll take you through how we can accomplish with the product offering that we as technical suppliers are offering you. Now the key question here is, what kind of services that actually need the seismic restraints? The short answer is all of the major MEP systems that are suspended from the structure or mounted to it, even if it is not a part of the building, but still essential for the operation, it is likely to be restrained. So if you can see from the slide, primarily there are two kinds of supports that require seismic restraints, and these normally cover 85 to 90% of the supports in your project. So one is the suspended supports, which is the most common category used for overhead services that includes all the piping, ductwork, cable trays that run above the false ceiling. And next would be the floor mounted supports. This will include heavy items like air handling units, transformers, pumps, and sometimes water heaters. These need to be anchored or braced directly to the floor or the structural wall to prevent them from sliding, toppling, or vibrating excessively in case of any eventuality. Now, seismic restraints, the solution is not like one size fits for all kind of a process. Sometimes it might be just spray braces that provide the lateral or the longitudinal supports to a pipe rack. Sometimes it can be a floor mounted anchors or wall brackets. So each one is designed for a specific load capacity, angle, and application. So we have a comprehensive library of certified products to ensure that we help you to select the right kind of bracing for the specified load, geometry, and seismic demand of each MEP component in the project. So in the coming slides, I will show you how these components are actually applied in a real world scenario. Now, these are some of the standard application details for seismic bracing, how we protect different pipe configuration. Like, let us then break down one by one. The first slide, what you see, give me a moment, let us break them one by one. The first, we have a single pipe lateral or a longitudinal support. Like, imagine this is a kind of a main header pipeline. So here we are providing the restraints in the two horizontal directions. One is lateral, another will be the longitudinal direction. This is the fundamental detail of restraining individual critical lines. And second detail, where you have a pipe rack, which will have multiple pipelines. It can be a PVC pipe, HDPE, or an insulated pipe, which is supported on a trapeze kind of a setup. This also should be restrained laterally or longitudinally, depending upon the situation what it is. Now, if you come to the third detail, where this, depending on the location of the support, the importance factor attributed to it, it might have to be braced in all the four directions. So here we have lateral and longitudinal supports placed on the same support because it has to be restrained in all the four directions. And similarly, we have for the pipe rack as well, where it's restrained on the both the direction. Now, the point here is the critical point for all these systems is a flexible bracing which is done on both the sides. And this is crucial engineering principle because the braces themselves should be connected with flexible fittings. You see here, so nothing is rigid over here. The reason is if the braces were rigid, they would snap immediately. So the flexibility allows the brace to accommodate the structural movement without breaking and maintaining its restraint on the pipe. So in summary, we select the bracing detail from a simple lateral to fully forward, depending on the pipe's importance and the seismic demands, which you always implement with flexibility in mind. Now, this is another typical arrangement. Sometimes you work in a corridor where there are multiple services are there, coming from all the three disciplines of HVAC, electrical, and plumbing, and you might not have enough space to provide bracing on both the sides. In those kind of scenarios, we replace with a slotted channel which can be anchored to the either side of the service and still which gives enough resistance to the lateral forces or the longitudinal forces that might come onto it in case of any eventuality. So here we are showing both the arrangements. Again, these are all rigid placing, but again on single side, where it will you are only anchoring it to one side, but still you are contracting on the forces which can act from both the directions. Similar kind of arrangements we have shown for ducts and cable trays as well. This is a flexible bracing, and this is a rigid bracing only on the single side. Now, moving on to firefighting, now this is a very important category. As Rajesh has explained you in the earlier slides, because rigid bracing is typically reserved especially for the fire protection sprinkler systems, because flexible braces allow some movement. And what happens is, because these things are so sensitive, that in case of any small movements, not because of earthquake, also can set off the sprinkler head and create a kind of water damage to the occupants who are in that building. But a rigid brace holds the pipe absolutely still during the smaller vibrations, preventing false alarms and water damages while still being strong enough to restrain it during a major seismic event. So the core principle here is that these braces are designed to be stiff connections with minimum flexibility, and they are used where we need to prevent any movement at all for every critical services. Now, if you see, observe these things, these components are independent, like in the earlier slides, you might have noticed that the bracing we are directly providing to the main support as well, but here it is provided separately because the code demands that it should be clamped separately to the pipe and directly to the structure below, structure above, whether it can be a concrete slab or it can be a steel structure above it. And then you have a seismic brace pipe, which is basically connecting these two. And these particular components have to be tested as per UL and FM standards as per the code. So this is about the firefighting. So these are some of the arrangements that we wanted to show you today, like how we are going to accomplish the seismic requirements of your projects with our product offering coming from Link Turkey. And now I give back the control to Rajesh to close the session. Over to you, Rajesh.
Thank you. Yeah. So moving forward, these are the references and codes that is being considered, whatever the content that is being presented. So these are the references that we followed and it's being extracted, like share seismic design for buildings of IBC 2000, 2002 and 2003, and AC, and also UFC code, which is being considered. So there are multiple chapters and multiple references that is being given in these codes, and with all these, we summarize this presentation. And so thank you all for your time. We will move on to the question and answers. And if in case if you want to contact us to discuss any requirements or anything related to this presentation or more question and answers, please scan this QR code so you can get in touch with us and you'll get our direct contact details. We will move on to the question sessions now. I think we have 10:45 now. We have 15 more minutes.
Okay, thank you, Mr. Rajesh. Firstly, I'd like to again remind the attendees, please, that you may freely enter your questions in the Q&A box. Yes, so far we've received 4 inquiries from the attendees. Likewise, a audio inquiry made by Mr. Vinu. Firstly, we would like to please address the question by Mr. Venkat Ramana.
Yeah, I
Please, Mr. Rajesh.
Yeah, so we have a question that Allama Hospital building in Shinaw, Muzaibi. What is the seismic category? Yeah, sir, I have been working with this. So it falls under category D, which we have worked out previously, and I think we already made a presentation inside. So the seismic category for Allama Hospital, which is in June to Muzaibi, falls under category D. And we have one more from Uzma, that please explain the importance factor for the structural members at the end. See, the presentation or the intent of this presentation is for the non-structural component, so which I have explained. You can reach us on the contact details which is being provided, so we can discuss in detail about the structural members, because we are deviating from the topic of today's. So I prefer it to be one-to-one. Yeah, thank you. And then moving forward, we have one more question from Mr. Venkat. If all HVAC, duct, firefighting pipes, and cable trays are supported with a common support, what is the seismic support requirement? Yeah, it's a very good question, because most of the project corridors, especially, falls under this kind of requirement where a huge number of services comes. So we must need to consider the house scenario. So if you compare a HVAC duct, firefighting pipe, and a cable tray, of course, in terms of design or in terms of functionality and life safety, the first priority one comes for the firefighting pipe. So if any of these services has got a higher importance, so the same is applicable for the subsequent services if they are attached in a common support, like one single support with multiple services, what Mr. Wazid has presented. So in such scenarios, we need to take the most critical aspect and then apply the same to the rest of the supports. And then moving forward, Mr. Piotr, please advise if there was any sustainable seismic event in recent modern history of Oman, its impact on EP components, if any. There is no such incident. I mean, there are seismic incidents, but it's not that majorly impacted any of the structural services here. But the frequency of earthquakes, which is happening in recent days, the numbers are more compared to either in the past. So the intensity of seismics, if you see, maximum happens in one region are like in a magnitude of 2, 3, not more than that, if I'm not wrong. But yeah, there is no major damage that is being created. And as I also know that most of the hospitals or most of the important buildings like public gatherings, malls, these are already being designed for seismic bracings. A prime example is our airport. Muscat Airport is being designed for all secondary elements are designed for seismic restraints. So yeah.
Okay, actually, Mr. Venu would like to have his mic activated. So I think he would like to share something. Go ahead, Mr. Venu.
It's activated. Yeah, yeah. At the end, I want to talk. Rajesh, you just complete the all the question and answers, and it is I can say something in the end. All the question and answers are completed.
Yeah, no, we have one more question from Mr. Haribasappa. Is there any free software to do the seismic support calculation? How get it authorized? See, there are softwares. If you can go back to the slides where the brand name Link API is presented, there is a software called Seismic Link, and I'll share after this presentation. I'll take the details, have your email ID. So I'll share the software link on your email so you can use it. It's free of cost. And yeah, for validation, you can approach us back to validate whether the basic inputs are considered or not. But validation is on the calculation, but the basic input, what we discussed here, either we need to follow the specification, so nobody can validate that. It should have a proper specification reference or the code reference, which needs to be taken care. So yeah, we have one more question from Mr. Jyoti. And what type of supports are allowed for heavy equipments like AHUs, chillers, and rooftop units? If it is a floor-mounted unit, as I mentioned previously, there are certain, it's again based on the weight and the height of the equipment. These needs to be designed for two aspects. One is for seismic and another one is for wind as well. Because if it's a heavy equipment and where you have a huge solid surface, so the wind impact also will be a critical one. So both of these need to be considered, which again comes with what we will say there, seismic anchors, which must be listed, which we highlighted in the presentation. And also if it's elevated from the ground at certain height, maybe 200 or 300 mm elevated up. So such requires a strong base support where either it is fabricated material, I mean, boxes or I sections, or it can be a modular steel profiles which can be assembled at site. So it's again based on the requirement, we can provide a design, but whatever the the type of equipment needs to be defined. And we have one more question. What would be possible to get a copy of PPT for the future references? Yes, Mr. Sam, sure, we will share you a copy of this presentation. It's not something confidential that we will hold it. So this has been the information that has been shared from multiple courts. So sure, we will share you a copy of this presentation. So with that, I would like to conclude the question and answer session as we are having another 8 more minutes. So I would like to, if any one has furthermore questions, please reach us on the contact details which is being provided. So it would be great pleasure for us to get in touch with you and discuss your further requirements or further discussions on seismic aspect. Yeah, with that, I would like to hand over the mic to Mr. Renu.
Yeah, thank you, Rajesh. Thank you, Rajesh. And it's very informative, and I hope everybody will get some benefited. But from text point of view, I would like to just highlight actually this, especially for this seismic topic. We were working with the various projects since 2 years, and what kind of services we wanted to offer, especially for this subject, apart from our selling of the product and everything. We initially involving every project and understanding the requirement of the clients and the specification which is mentioned. And based upon our experience, there are some seismic product to be used, but we have proved to the client and consultant by showing the codes and everything. We eliminated majorly 90% which is not required, and that will be saving the time. And when it is not required also, maybe specification says seismic, but we have all clearly proved and studying entire requirement and specifications, and we proved that there is a requirement. So that is the advantage, and we are having a team of engineers under Rajesh, and they are well trained. And we will be visiting based upon your requirement any of the seismic, and we will be giving a full study of what is required, what is not required, and which places are required. That is number one. And optimizing the solutions also, which we are able to do it. It is not just like because of seismic it is used. So this is our request. Any of your inquiries in the initial stage or design stage, wherever it is a seismic it is coming, and we request everybody can approach us, and we are happy to give you our technical services. This is number one. And any of the engineers who wanted to have a separate session for the seismic and how to select the seismic and which zone to be there and all. So we have conducted a couple of seminars to some consultants, and we are happy to share this knowledge to everybody. And please feel to reach us, and we will be coming, and maybe at your place like 2 to 3 hours we will be able to give all the technical seminar about the seismic requirements. So once again, I thank you, and Mr. Marian, you can conclude the session because it's already 10:55, and definitely we will be in touch with them as and when required. Thank you very much.
Indeed, indeed. All right then. So as we conclude our session, thank you very much for joining us today. We hope this session deepened your understanding of the seismic design and code compliance for MEP systems and offered practical clarity you can take back to your projects. Please feel free to contact our engineers. We'd be more than happy to share this knowledge with you all. And we are very, very happy to receive these calls. And a warm thank you to our presenters for sharing their expertise, and to each of you for participating in this lovely session. Please, thank you so much, and you all take care now. All right, I'll be ending the session. Goodbye.
Yeah, thank you.
Marian, once you end this session, they can able to question.